Hello everybody. In this question, we are told that a line has an equation y equals 2cx plus 3 and a curve has an equation y equals cx squared plus 3x minus c, where c is a constant. So we need to show all the necessary working to determine which of the following statements is correct, say B or C. Let's read the statements to find out what they are looking for. So the line and curve intersect only for a particular set of values of C, or the line and curve intersect for all values of C. The line and curve do not intersect for any value of C. So obviously the most common thing here is we need to find whether the line and curve intersect. If they do, for all values or some value, or they don't intersect at all. So to do that, all that we need to do is we have y is 2cx plus 3 and y equals cx squared plus 3x minus c, so we can equate them. So let's start that. So if I write down it again, 2cx plus 3, and we also have y equals the equation of the curve, so cx squared plus 3x minus c. So equating, we can say 2cx plus 3 equals cx squared plus 3x minus c. So then we can write, bringing it all to one side, we can write that cx squared plus 3x minus 2cx, so plus 3 minus 2cx plus minus c minus 3, so that is equal to 0. So you see this is of the form ax squared plus bx plus c equals 0. So obviously then the next thing, for any kind of solution to exist, we need to have the discriminant b squared minus 4ac greater than or at least equal to 0. So for any real solutions, if you start from there, so for real solutions, if I say that b squared minus 4ac is equal to 0, or b squared minus 4ac is greater than 0. So if we start with equal to 0, so what is b squared minus 4ac? So b squared minus 4ac is equal to, here b, so I should probably write it as, so small a b, all the c, and that will it doesn't matter. Okay, so it's not, it's a big capital C, I can say, and it doesn't matter. So b squared minus 4ac here, the discriminant, so I say discriminant. Yeah, okay, discriminant. So then here b squared, that is 3 minus 2c whole square, minus 4ac, so minus 4 times ac, and c is here minus c minus 3. So I can write this as, so that is equal to 9 minus 2 times 3 is 6 times 2 is 12 plus 4c square plus 4c square plus 12c. So then that is equal to 12 c's get cancelled out. We get 8c squared plus 9, which is definitely greater than 0 for any values of c, you know, for any value of c. Okay, so that's any, for any value of c, right? So for any value of c, you'd have this, whether negative or positive c. So this is greater than 0, so solution is possible. Hence, our answer is B, for the line and the curve will intersect for all values of c. So here, this is the answer.